So now we're to a topic that I think is probably the most important one for the entire course because a lot of the things that you're going to do financially the rest of your life is to borrow money and pay it back. So I wanted to talk about why things work the way they do before we really start getting into the topic in more detail. So installment loans, also known as partial payments of loans, came about the turn of the 20th century um, before partial payments were allowed. If you did make a partial payment on a loan, it did not do what you would expect it to do. Before this law, the U.S. rule came into effect, if you borrowed $1,000 and you were charged $200 of interest, they would expect $1,200 from you, whether you made payments up until the $1,200 or if you waited until the end of the term of the loan it was over and paid $1,200. So it was kind of unfair that if you made a partial payment, the bank had use of this money, but you still had to pay interest on it. So the U.S. rule stated that if a person made a partial payment of a loan, they would pay the interest up to that date of the payment, and then the remaining amount of their payment would go towards the balance of the loan. So it took care of two things at once. It made the banks happy because they were getting their interest, and it made the people happy because it was reducing the amount of the loan and therefore reducing how much interest they would owe later on. So let's take a simple, loan and create one, and we're going to do what's called an amortization. It's basically a breakdown of this loan. So we're going to do it on a monthly basis. Um, the original U.S. rule didn't care if it was monthly or whatnot. So nowadays we just basically do monthly payments because that way it fits into most people's budgets are monthly, and then they get 12 payments a year. All right, so let's just create a fictional loan with a simple interest rate. Well, it's technically compound interest, but simple as in easy to work with. And then I want to show you something that happens. So let's say we borrowed $1,200. So this is our principal. Let's say we are being charged 5% APR, obviously compounded monthly, but the compounding will be part of this table, and you'll see that in a little bit. And let's just, for instance, say I want to pay this off over 3 installments. So my table only has 3 payments on it. So if we're going to pay it off in 3 installments, most people would go, oh, let's take the $1,200, divide it by 3, and make payments of $400 each. And that should pay off the loan. And most people would think this way, which is kind of scary. So let's go through our table and set it up. So I always put a month zero or a payment zero in here just so we can say there is no monthly payment, there is no interest. This principal payment is the second part of the U.S. rule where it says the remaining amount would reduce the balance. So the principal payment is just going towards the balance itself. And our balance for this loan is $1,200. And that's why I like the zero payment, to show that we have a beginning balance of $1,200. All right, so our monthly payment is going to be $400 each. So I'll put 400 here, 400 here, 400 here for a grand total of $1,200. And then to find the interest, the U.S. rule says to pay the interest to date. So if we are making this a monthly payment, then the amount of time that went from 0 payment to 1 payment is 1 month. So when we do our interest, it's going to be interest for 1 month. So and I'm not going to write out the formula, P is $1,200, that's our balance. The interest rate is 5%, and the time is 1 month out of a year. So we get 1,200 times 0.05 times 1/12 times 5 over 100 times 1/12 for a grand total of $5 of interest. So the amount of interest that we're going to owe for that first month is $5. The principal payment is going to be how much is left over, because the bank wants their $5 and they're going to take it from the $400. So your principal payment literally is going to be $400 minus $5 for a grand total of $395. Now the $395 is going to be taken away from the previous balance. So we're going to have $1,200 minus $395. For a grand total of $805. So that means our balance now is $805. All right, so now we get to our second payment. Now, the amount of time that has gone by, again, is 1 month. This new balance of $805 was only on the books for 1 month, so we're again going to get charged interest just for 1 month. So we're going to get the interest is equal to my balance, which is $805. My interest rate never changes, 5%. The amount of time for these tables are always going to be the same time frame. So if it's daily payments, it would be 1 out of 365. All right, so let's calculate this out. 805, 5% interest, 1 month out of a year. So $3.35 in interest. Oops. So the interest is $3.35. All right, and again, that $3.35 is going to come from the $400 minus $335, and that's going to leave us $396.65 as our principal payment. And then we're going to take our principal payment away from 805. And by now you can see that by paying $400 each month, we're not going to be able to pay off this loan. So on this last month, we have another month of time frame. We're paying $400. My interest is going to be based off of that $408.35. We're going to multiply by 5 over 100 and 1 over 12. 835 times 5% interest times 1 month. It gets kind of repetitive. 170. So $1.70. And then we're going to subtract that away from 400. This will come out negative, but 398.30. 398.30. And then if we subtract that from the 408.35, $10.05. So at the end of all, we would still owe $10.05. So just dividing the principal into equal payments over a time of the loan period is not going to pay off the loan, because what becomes important here is this interest has to be paid to the bank. So the bank's going to want all of this money. So be careful when you're getting a loan not to think of it as taking the principal and dividing it into how many payments you're making to figure out how much your monthly payments are, because it's a lot more complex than that. So to better handle finding the precise or a closer value for the monthly payment so that when we're done with all our payments, our balance should be really close to zero. Are usually found on bank websites, and I used to link them into my class, but they would always change, and it became kind of tiresome. So I designed my own little finding a monthly payment for a loan function in a program. And if you want the link to this, I can always send it to you. So we have a principal of a loan, and that's what would be entered here at the top. How much are you going to borrow? The interest rate, but not as a decimal. So if it's 5% interest, you just put 5 in there. And the number of payments, or the number of months that you're going to be paying this off over, would go in here. So our loan was $1,200. The interest rate was 5%, and I wanted it done in 3 payments. So the correct payment to get the balance really close to zero would have been $403.34. So this calculator is really nice, especially like if you're going to be, purchasing a car. And cars usually go about, $22,000, let's say, is how much you would borrow. Interest rates lately have been kind of low, so I'll put in 3%. And most car loans are for 48 months. So if you put all this information in, you would find that your monthly payment is $486.96 a month. You make 48 of those payments, and you'll be done with the loan. So it's kind of a neat little calculator. Now, if you didn't have the calculator, you would have to have the formula. And I'll show you the formula, and you'll see why you really don't want to use it. So the formula would be, and I'll tell you what all the letters mean after I'm done writing it, because I got to remember certain parts of it. The principal divided by, this would be times r over n. This would be 1 minus 1 plus r over n raised to the negative nt. So it kind of looks like the compound interest formula is built into it. And this would be the formula to find the required payment for an amount you borrow, and then the r and the n and the t all represent the same thing in terms of compound interest. The only weird thing in this whole formula, I think, is that negative nt. And I used to teach this formula, but then it became too troublesome for the students to get the answer correct, because this is kind of messy to type into a calculator. And it wasn't that informative to type all this into your calculator and get an answer. So I opted for the web version loan calculators that you can find. But if you want to use the formula, be my guest. So now that there's an easier way to find a loan payment, we can ask actually much more interesting questions based on that. All right, so let's put this to use. I'm using the information that we just generated with the calculator. You are borrowing $22,000 to purchase a brand new car. The dealership will give you 3% APR over 4 years, and your monthly payment turned out to be $486.96 every single month. So my questions usually will turn out to be things like, how much will the car really cost you? Sure, you're buying it for $22,000, but you're buying it with a loan, so that means it's going to be more than $22,000. So to figure out how much you're going to truly pay, this is one of those common sense things. We know that we're paying this much money, $486 every single month for 4 years. So it basically becomes your monthly payment times the number of payments. So the total is always going to equal your monthly payment times number of payments. So in this case, it's going to be 486.96 times 4 years, but each year has 12 months, So that would be 48 payments. So this 4 years, you have to be careful. You have to change it into number of payments, and it's usually monthly, so you'd multiply by 12. So $23,374.08. So that would be how much you really are buying your car for. Because $22,000 will go to the dealership, what's left over is going to go towards the bank. So that brings us down to our second question. How much interest is the bank actually going to get out of this deal of lending you $22,000? Well, that goes back to um, an older formula where interest is equal to the future value minus the principal. Future value in this case being the amount of money, the total amount of money you're paying for the car, and the principal is how much did you really borrow. All right, so here we're going to get the interest is equal to $23,374.08 minus $22,000. So the amount of money that the bank is going to earn, color code this, is going to be $1,374.08. So that is money that is just being paid to the bank for the use of the money to buy the car. So these are the types of questions that are more interesting than just figuring out how much is the monthly payment. Because it's after you have the monthly payment that things start to come together and we can figure out how much are you really paying and how much of it is going towards interest. So sometimes a dealership will have pricing options, and usually what will happen is if you can make a down payment, the interest on the loan becomes smaller because you're proving to the bank basically that you can save money. So here I have a dealership has two purchasing options. Option A is a 5% APR for the entire cost of the car, no down payment required. B has a down payment of $3,000, but if you do that, the interest rate goes down to 3%. So you save 2% APR. And the question becomes, which one is a better deal for you? So you want to purchase a car that costs $28,500 and plan to pay it off over 6 years. Which one should you choose? All right, so for both of them, you need to, pull apart the information so that we can discuss them a little bit more in detail. So the principal for the first loan is the entire cost of the car. The interest rate, of course, is 5%, and the number of payments is 6 years, but remember, it has to be 6 times 12 because you're making monthly payments. 6 times 12 is 72. All right. Now, the principal for Plan B, after a $3,000 down payment, now a down payment doesn't say that you're going to still borrow $28,500. You're actually paying part of the cost of the car, so you're going to reduce your $28,500 by $3,000. So your principal now is going to be just $25,500. All right, the rate, of course, is now down to 3% because of that down payment. And the number of payments is going to stay the same. It's still over 6 years. So now you can go to the calculator to figure out your monthly payments. So that's that is going to be what includes the interest, and that's the unknown quantity here. How much are we paying in interest for both of these cases? Okay, so let's go to our calculator. 28,500, 5%, 72. And we get a monthly payment of $458.99. For option A. And then option B, we just have to change a few things. 25,500, 3%, 72 months. 387.44. So now we should be able to determine how much the car cost under both cases. So you have to keep this kind of simplistic. Any money that comes out of your pocket is paying for this car, whether it is a down payment, whether it is a monthly payment, whether it is interest. So we have to account for all of that differences. So with a monthly payment, we can at least find the total amount paid for the loan, not necessarily the car. So the total amount is going to equal the monthly payment times the number of payments. So this is going to be how much it costs for Plan A. There was nothing else going on. This is all the money that came out of your pocket. So
458.99 times 72. So 33,047.28.
Now, that's how much the car would cost under Plan A. So to find out how much it would cost under Plan B, it starts off basically the same. You're going to take your monthly payment. You're going to multiply it by the number of payments. And that'll give us $27,895.68. Now, this is the total amount paid to the loan. This is not how much was paid to the car. To account for the car, we need to go back up to the top here and worry about this $3,000 deposit. So, or down payment. So we're going to have to add on to this $3,000 that we also paid towards this car to come up with its final total payment. So the amount of money you paid for this car is $30,895.68. So this is total for car. And that is still better than $33,000. So Plan B, even though you made a down payment in the beginning and reduced your interest, it saved you money in the long run. I think a better way of going about loans is not worrying about finding the payment. I think it's better if you have a budgeted amount of money that you can afford for paying off a car to look for the maximum loan amount that you can actually borrow. So, how much of a loan can you afford? So, let's say we have you want to purchase a car but can only afford $250 a month. How much can you borrow if your bank offers a loan at 2.5% for 3 years, 4 years, and 6 years? So, generally, what will happen is the shorter the period of the time, the bigger the payments. But then on the converse side of this, the longer the loan is, the more interest you're going to pay. So I want to talk about all of these concepts with this simple example. All right, so I have another calculator. It's called the maximum loan calculator. It looks like this. And all you have to do is, again, put in how much you can afford, the interest rate, not as a decimal, but straight percent, and then how many payments you're going to make. Now, 3 years is 36 payments, 12 times 3. So the maximum loan you can get for $250 a month over 3 years is $8,662 and 10 cents. Okay. And then for 4 years, if you're going to make payments of $250 at 2.5%, we only need to change the time to 48 months. And now we can afford 11,408. I really shouldn't put the pennies, so 11,400. I'm going to change the number above it too to 8,600 because we're just ballparking this. Let's go 8,660. Okay, so 6 years here. We'll change, dang it. We'll change the 48 to 6 times 12. Now, you can, if you want to get fancy, is put 6 times 12 in there, and it'll do the work for you. It's 72 months, and now we can borrow about $16,700. So $16,700. So as we increase the time in the loan payoff period, we can increase the amount of money we could borrow for our car. All right, so now let's look at the other possibility. How much interest are you paying under each case? And are you willing to, pay it? So this, again, also becomes kind of easy. For 3 years, we know our payment is $250, and we know we're paying it off 36 months. For 4 years, we're paying $250 over 4 years, which is 48 months. And then for 6 years, we are paying $250 a month for 72 months. All right, so we just need to figure these out. This will be the total cost of each one of the cars, assuming you're not doing some down payment or other. So 250 times 36 is $9,000. 4 years, 250 times 48 is $12,000. Is $18,000. So these are the amounts that you would really be paying for each one of the cars. All right, so if we want to find interest, we just need to subtract the amount we borrowed from the amount we paid. So these are the amounts we paid, the $9,000, the $12,000, and the $18,000. But the amount we borrowed was $8,660 approximately. Here it was 11,400, and here it was 16,700. All right, so for the first one, let's see, that's 0, 4, 3, $340 of interest. That's not bad. Of course, then you're only borrowing $9,000 for 3 years. This one would be 006, $600 of interest. And this one would be 003, 1,300 of interest. So you can see that, sure, you can buy more of a car, but you're going to pay for it in interest over the long period. And I have a warning about any 6-year loan. Anything technically over 4 years becomes kind of dangerous if you're on the edge of a budget. And that's because most cars require service after about 3 years. New tires, new battery, shocks, mufflers, anything like that. And if we push it towards 6 years, you're going to be doing more repairs. So you also have to contend with a budget for repairing your car and paying for your car at the same time. So I always lean towards a 4-year loan. By the end of your 4 years, you've paid off your car, and then you can use the money that you budgeted to fix your car up. Now, besides car loans, mortgages are the most common type of loan out there, and they also happen to be the longest loan out there. So, when you're talking about mortgages, basically it's just a loan to purchase a home. As simple as that. So, it's just a fancy word for a loan. So, the Jacksons want to buy a house for $175,000. The bank will offer them a 30-year loan at 3.5% APR. after the Jacksons pay a 15% down payment. Now, most banks require a down payment up front before they'll give the loan out because they want to more than guarantee that you're going to pay this amount of money back. It's because it's, well, a lot of money. The bank is going to give you this much money, or give the Jacksons this much money towards purchasing their house, so they want some guarantees that the Jacksons might be able to pay it off. All right, so the first thing you have to do here is not worry about the loan right off the bat. You have to worry about the 15% down payment. So to start off, we're going to take 15% of $175,000. And of course, to do that, we're going to do 15 over 100 times $175,000.
100 times $175,000.
So 26,250. Oops. So before they can even get the loan, the Jacksons have to come up with this amount of money, give it to the bank, and then the bank will, loan them the $175,000. Now, the bank isn't going to loan them $175,000 anymore because they made this down payment. So we're going to have a principal that is equal to the cost of the house minus the down payment. It's going to reduce the amount of the loan. All right, so
26,250.
So 148,750. All right, so this is how much money the Jacksons will be borrowing, and they are going to be doing it for 30 years at 3.5% interest. So now we have to go to our calculator. Find our monthly payment. Let's delete all that out of there. So the principal is $114.8750. $1,487.50. The interest rate was 3.5, and the number of months was 30 years. And again, you can do this in the calculator. 30 times 12. It's 360, but just in case you didn't remember. So our monthly payment is going to be $667.95. 66,795. 66,795. And this will be per month, and you will be making 360 payments. Okay. All right, so that finds our monthly payment. So my next question would be, how much are they paying for this house? Okay. So if we're looking for how much the Jacksons are paying, we have to account for all the money that has come out of their pocket. And the first thing that came out of their pocket was the $26,250, the down payment. So that's part of how much they paid for their house. The rest of it is going to be from the 360 payments of $667.95 per month that they've paid for this house over that period of time. So altogether, so the Jacksons over 30 years will pay $266,712 for this house. Now, generally, When you do a mortgage, it's almost twice as much as the house cost to pay it all off. So if they bought a $175,000 house, I would expect around $300,000 to pay off this house on average. 3.5% is a low interest rate, but still, that's a lot of money to come out of someone's pocket. And that's why mortgages are so um, overbearing on people's budgets. All right, so then the next part of my question would be um, how much interest did bank charge? Now, this is not the interest rate. This is how much money went towards the bank, and not how much money went towards the house per se. So when we're talking about interest, it is the total amount that you paid back minus the cost of the house. So here, the amount of money that we paid, or the Jacksons paid, is this. And the amount of money the house should have cost if they could have just paid cash right at the beginning was this. And if we subtract them, anything that's above and beyond the cost of the item, in this case the house, is interest.
So I'm going to subtract from this number minus 175,000 and $91,712.
The $91,712 is the amount of money the bank is earning by lending the Jacksons the money to purchase their house. Up a loan amortization based on the Jacksons' loan. So they're borrowing $148,750 at 3.5% for 30 years, and then this is their monthly payment. And I showed you how to do this by hand at the beginning of the video, so you should be able to set up a spreadsheet based on those pretty simple formulas. There's not much dollar signage going on here except for that. The 3.5% is the only constant for this entire problem. Well, and the 667.95, but that you should be able to just copy down. All right, so I always set it up as a zero payment at the beginning. Nothing happens with payment, interest, and principal pay, and at least it shows the balance, and then I'm just stealing it from there, so equal that. And then on the first payment, this formula, by the way, is real easy. It is 1 plus the cell above it. So if I put 0 in the cell above it, 1 plus it is going to be 1. And if you copy it down, 1 plus 1 is 2, and so forth and so on. So I put in my monthly payment. This is the amount of interest for 1 month on $148,750. And then that is going to be taken by the bank and out of your payment. And the only amount that's going towards your principal is $234. So you almost pay $700 towards the bank, and they're only going to give you $250 for your balance. So that's where interest gets paid the most, at the very beginning of a mortgage. All right, and then after you make this principal payment, it reduces your principal, and then your next interest is going to be based off of this. So let's see what happens with the interest as we go down. You'll see that the numbers are getting smaller. So let's go to 10 years, which is like 120 payments. Now be careful. This is a row address. This is the number of payments. So I'm looking at this number here. So if I go to 10 years, which is 120 months, or 120 payments, we end up still making this payment, but now my interest is only $336, $337. And more money is going towards my balance, which is good. So as time goes on, the amount of interest you pay goes down, the amount of money going towards your loan goes up. So there's a little balancing act going on between interest and principal payment. So if we are going to refinance a loan, which is probably a good thing to do if your interest rate is really high, 3.5% is pretty good. So the Jacksons, if they're going to refinance, they'd probably just shorten the term of their loan. But some people that have a high interest rate will refinance either after 10 years or 15. Let's get to 15 here. 15 is 180 payments. And you'll notice here that the interest is now down to $273, and we're almost paying $400 towards the principal. So if they were going to refinance after 15 years, the amount of money they'd have to get a loan for, you're going to pay off a loan, in this case, with a loan, which is weird, but it happens all the time. They would have to get a loan for about $94,000. And then hopefully they get a smaller interest rate, and hopefully they would save money. So there is a project that you have to do that is a refinance project based on this idea of refinancing and then finding how much you would pay under the old method and how much you would pay under the new method. So the last thing I want to talk about is at the end of a loan. So after you amortize a loan, it's supposed to end at 360 payments, and your balance should be zero. So you'll notice here that my balance is, I still owe $2.49. So what happens on the last payment of a loan, if it doesn't pay off the loan completely, is you do what's called a balloon. So we're going to do a balloon payment. We're going to change our payment here to account for this extra $2.49. So over here, I'm going to change this by just adding $2.49. And by doing that, I get a loan balance of zero. So this is what's called a balloon payment. There's other ways of handling it. For instance, if you made a larger payment up above than the $667, then that would change a lot about this. Plus, you couldn't just multiply to figure out anything. So be careful of that. So balloon payments, to get it equal to zero, you have to adjust your last payment.